Hey, welcome back, class. Hope you're enjoying the semester so far. You're getting something out of it. You know, this week we are going to be discussing safety. However, this is actually a topic that you could spend an entire semester on, in all honesty. Safety is a big part of the water industry, and for a lot of reasons. We work in a lot of hazardous environments. You're working up high, you're working in confined space, you're working in traffic, you're working in trenches. Um, yeah, the list goes on. There's a ton of different safety factors that we have to be aware of in order to, do our job safely, and so we could go home at the end of the day. So, with that, let's dive in. Uh-oh. 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 All right, I hope you guys enjoyed that. That was a video I put together towards the end of my operational career where I was responding to leaks. Yeah. Uh-oh. All right, so as you can see here, we've got a short list of topics, and I say short list because it really is. There's a lot to this topic. And speaking of which, we're going to split this lecture up into two separate videos just to make it a little bit more digestible. And everything that we're going to go over today is very high level. I'm not going to get really into the details on a lot of stuff just because there's so many nuances to everything. But yeah, personal safety considerations are a huge part of this. Regulatory requirements, again, a very large part of safety. But then, yeah, you get into PPE, you get into hand tool safety, material handling, traffic control, trenching safety, a lot of things that I said, there's a lot of, you know, aspects to our job that present a safety factor or a hazardous factor that we need to be aware of. So what makes up a safety program? Well, there's a lot of different things. Lockout, tagout, natural disasters, OSHA, being CPR certified, these are all different areas that make up the safety program. And this is a short list again. This doesn't encompass everything that goes into it. So, who's responsible for what when it comes to safety? Every level of where you're at in the organization holds a different responsibility when it comes to safety. So employees have their own, responsibilities, supervisors, managers. Everyone has their own level of safety or responsibility when it comes to this. So the primary responsibility for individual safety in the workplace is the employees. That is you. That's everybody, right? You have to be responsible for your own safety in order to keep yourself safe. Um, you can't just blindly go into any task and start performing it without taking a step back to consider, are there some, hazardous aspects that I should be aware of, to prevent myself from being injured or killed. So always be safety oriented, safety minded, to keep yourself safe first. And if you identify some, some hazard, you need to hit the pause button, you need to call a timeout, whatever you got to do, and then bring it up to somebody. So that way, they're aware of it. You can discuss it. Maybe it's just a perceived thing. Maybe you think there's a safety aspect or a hazard uh, associated with the task that you're doing, and that maybe there isn't. It's just a good idea to clarify anything that you may be wondering about. So, as a supervisor, when it comes to safety, it's their role to make sure that you are trained and that you know how to communicate the safe practices. Um, yeah, they should be setting the example. I know that I tried to do that even before becoming a supervisor. I would always take the steps necessary and wouldn't just solely look at, like this list in front of you and say, oh, that's not my responsibility. I kind of just took it on, um, just because it helps the program, it helps to keep everyone safe. And supervisors have a lot going on. Ultimately, this is their responsibility to do all of these things. But you, as a line level employee or wherever you're at in your organization, you as yourself should be doing these things just to make the program effective. So when you get into management, though, things will change a lot because you really, as a supervisor, you're more of a technical expert. You're probably going out into the field and, supervising the guys. But once you hit to a manager level, you're taking like a step back even further. So now you're kind of overseeing the program itself and, doing more of the administrative side of things. So as you can see, management's responsible for both the maintaining the safe working conditions and for supporting the policy, right? Like I said, um, you know, administering the program. Um, but they are going to be responsible for the developing the training programs, and the list is long, right? Um, if you have ever had to recertify for any of your distribution certifications or your treatment certifications, you know that you're only allowed to use so many hours for safety, which is kind of unfortunate because it's so easy to find topics on or trainings on safety. They want about three-quarters of the hours that you need for your contact hours to be technical, and only about a quarter of them can be for safety. But the manager is also responsible for setting it up and, whether that's committees or having meetings and making sure that you're all aware of this stuff too. It is their responsibility to monitor it and make sure that program is working. If you start getting a whole bunch of workman comp claims, you then have to worry about your insurance providers raising rates or dropping you. Um, but then just making sure that your plan is in action, making sure that everyone is aware of, the hazards that are associated with their position and that they have the proper training prior to, you should have the proper training prior to going into any uh, hazardous situation. Like if you're going to be working up high, you should probably have fall protection training. If you're going to be working in a confined space, having confined space training, right? So making sure that, the plan is in action and that, employees are taking the steps necessary to keep themselves safe. Like I said, the primary responsibility to provide a safe work environment, including adequate training, supplies, and enforcement, is the employer's, right? So it is the employer's responsibility to make sure you have boots. If have worked at an agency by now, you typically see they have a boot allowance where you can go out and purchase the proper safety shoe that fits you and works for you. Um, they should be making sure you have gloves, hard hat, vests, hearing protection. It is their responsibility to provide these things for you. If they are not providing these things for you, well, you might have a case for litigation. Um, it's if they're going to put you in this environment to do a job for them, then they need to give you the adequate supplies and tools in order to be safe. All right, regulatory compliant or requirements. Uh, this is what they will use to take you to court if you're not following things, you know. So it's important that um, employers are very aware of these, and these get added upon, rules change, regulations change, to be in compliance. You really have to stay up on all of these because these things change frequently. But there is the Occupational Safe and Health Act, right? Not to be confused with, the Safety and Health Administration, right? So the act is what gives OSHA the the teeth to do their job, right? Um, there are obvious reasons for this. Obvious reasons for this are to prevent or eliminate suffering, injury, and possibility of death, right? All of that costs money. Your employer spends a lot of money to train you and to bring you up to speed so that way you can do your job effectively. And so when you are injured on the job, that's a huge cost to them. When you die on the job, that's an even bigger cost. So, and that's where the leverage comes in, right? For these administrations, right? They know that they can hit you in the pocketbook, and that's where it's going to hurt the most. So yes, there's a cost to the utility, lost time, medical costs, damaged equipment, repair costs, and legal judgments. So getting into, like I said, litigation can be a big factor for your employer should you get hurt on the job. Right, PPE. For those of you who haven't been in the industry yet and are trying to get in, PPE is a huge deal. It's important to use these things. Speaking from experience, there's been a couple times in my career, just being honest, where I wasn't wearing the proper PPE and I did get hurt. Um, so hard hats are a huge one. Those will prevent things from falling on your head and hitting you. However, they do make high visibility hard hats, and that's typically why they're white, because it stands out to, drivers. And so you got to make sure that your hard hat is visible. That's why you don't typically see them covered in stickers anymore. A lot of times in the past, you'd have hard hats that were just, covered in stickers. However, it reduces the visibility. And so that then you have to replace it or scrape them all off. And hard hats are only good for a certain period of time, right? After a few years, you typically need to exchange it out, and that's hard to do sometimes because your hard hat becomes comfortable. It's like a good pair of running shoes that you just don't want to get rid of. But the hard hats really are only good for a certain period of time. Gloves, that's a huge one. You got to make sure that you're using the proper type of glove for the task that you're performing. Um, Typically I was wearing the leather gloves all the time when I was doing construction. But then when I was an operator, we had like these rubber type gloves that were more suitable for working on with smaller parts. And then you got welding gloves, you've got rubber gloves for working in a lab. There's a whole bunch of different types. So if you're using gloves, you want to make sure that you're using the proper ones. Safety glasses versus safety goggles. One will prevent splashing, the other one's just kind of preventing flying debris. You have face shields for that too. Like I said, steel toe boots or walking shoes. If you're a meter reader, you probably just need walking shoes. Respiratory equipment is definitely important, especially if you're going to be working in a confined space or if you are working around aerosols. The different types of hearing protection, there's earplugs and ear muffs. You need to know that like they uh, the difference between the two obviously is one goes in your ear and the other one just covers your ear, but then also paying attention to the decibel level that they reduce and the environment you're going to be in. Yeah, you may need pepper spray if you're going to be a meter reader and you're going house to house. You might need something to protect you from, stray dogs. Again, fall protection, you're going to need vests, like or a harness, and then road vests, making sure that those are a type 3. Those are the only ones that are approved nowadays, and those are the ones that go over your arms and provide like like a short sleeve for you. If you if you get one of these vests and you're a smaller person, they don't make the road vest type or the Type 3 road vest in a small anymore, just because there's not enough room for the reflective material that they put on them. So you're going to be stuck getting yourself a medium or larger or however large. All right, your safety program. um, what goes into it, or it's incident investigations, hazardous identifications, training, emergency response. You've got ongoing inspections, hazard control, program administration. Like I said, there's a lot that goes into every single health and safety program. And that's just because it's important for you to be safe, and they want you to go home at the end of the day. So there's usually going to be some kind of a policy statement, training, promotions, right? Promotion of the program, sorry. And then, like I said, if you get in an accident, doing some kind of an accident investigation, typically when your accident goes over a certain dollar amount, they're going to send you in for testing to, cover their butts, I guess, if you will. But doing some kind of drug testing or alcohol testing to make sure that you weren't under the influence when the accident happened. Obviously, reporting. When it gets to a certain point, you do have to notify your insurance provider, uh, and they're gonna, because they're likely the ones who are gonna be paying for it. Material handling. This is I've gotten hurt, not using proper lifting techniques. But I wasn't at work at this time. I was just moving into my own place, and yeah, that last box, as I was trying to rush, used improper form, and definitely created some sciatic pain for myself. So use proper form when lifting. If there's no help available, use a tool or just wait, you know, uh, wait until somebody comes around. And if they're inconvenienced by the fact that you can't move something that's heavy, they'll probably help you lift it and move it for you, work as a team. You definitely want to stay clear of any loads that are above you or being transported. You never want to stand underneath it. That's just a recipe for disaster, right? They make all kinds of special lifting clamps, for like valves or hydrants, anything that's, used frequently, but, probably too heavy for one person. They definitely have, um, tools and, materials that are out there to help you do these, lifting tasks. So just making sure that pay attention to, one of the most common, like it says here, most common, most debilitating types of injuries uh, related to material handling is back injury. And it's usually because we're in a rush. So do what you can to keep yourself safe. Lockout, tag out. Okay, what is lockout, tag out? And this is one of those things that's used everywhere, right? Everywhere you have some form of lockout, tag out. And it's anytime you're going to be working with a hazardous energy. So what is a hazardous energy? That could be anything electrical, mechanical, hydraulic, pneumatic, chemical, thermal, etc. Right? And what you want to do is, prevent that hazardous energy from affecting your work area, or affecting you when you go to work on these things. So like your water mains, right? You typically do shutdowns. You're not doing like a lockout tag out per se. In some cases you might be, because if there's easy access to valves, um, you might have to drop in little valve stand locks. But if you have water that's coming from a treatment plant, or you're working on an electrical system at a treatment plant, let's say, you definitely want to power that down, and you install locks on it to prevent anyone else from just turning that power source back on. In the way it works too, you also want to make sure that the person who locks it out is the person who unlocks it. Unless, there's an extenuating circumstance in which that person is no longer available to unlock the lockout tagout. then it's usually a supervisor or a designated employee who has that authority to go in and unlock it. Okay, but that person's usually going to be involved in the project and is aware of, the status of the project prior to turning anything on. So the OSHA standard for lockout tagout is the 29 CFR 1910 147, and that will cover the um, procedure for addressing and controlling the hazardous energy, training, recognition, specific procedure limitations, and then of course retraining. As you can see in the image to the right here, uh, you have a lot of people who are working on this system. And so what they've done here is that they've installed a locking mechanism that other individuals who are also working on that system can install their lock on it. So just because you were the first one to install your lock and you're done and you're ready to go, that may mean that, there's other people working on it who are not, ready to go. So you got to make sure that everyone is done working on that system prior to re-energizing it. All right, there's fire classifications. You have, not every material can be put out with the same device, like a fire extinguisher, for example. Um, Different materials burn differently. So, like, you can have a fuel fire, you can have a carbon fire, you can have a chemical fire, right? There's different extinguishers that are required and knowing which type of extinguisher that's needed is equally important, right? So like I said here, you got A, B, C, D, and K, right? So become familiar with those, just for your own information, because if you come across one of these fires, you want to make sure that you're using the right retardant to put the fire out. Like you don't want to be using um, like obviously water on, let's say, an electrical fire, right? You want to make sure you're grabbing the proper extinguisher. If you're going to be working with acids and bases, it's very important to understand how those interact with each other and making sure that you have the proper PPE. Like I said earlier, you want to make sure you have the rubber gloves or safety goggles to, prevent splashing from getting into your eyes, or a face shield to prevent it from hitting your face, right? Or in some cases, you'll wear both at the same time. Um, You'll see this on a test at some point, but when you're diluting acids, you always want to pour the acid into the water, not the other way around. The reaction can be very fast, and so by putting water into an acid, it's going to create a reaction. Whereas if you go with an acid into a water, it's less likely to have a catastrophic reaction. And then you want to work over a sink and not over a tabletop, right? A sink is better equipped to contain any spillage, and you're not having to wipe it up. Um, so you don't want to be working over a tabletop by any means. All right. Like we've talked about before, trench safety, right? Excavations are an extremely dangerous place. So knowing that, so here's some of the just the numbers that you need to know, right? You need to have a ladder within 25 feet of you. So if you have a 50-foot long trench, you could technically put a ladder right in the middle of that and you're going to be compliant, right? And then that ladder needs to extend 3 feet above the trench. Or if you're climbing up on top of a reservoir, for example, the ladder needs to be 3 feet above the whatever it is you're climbing out of. Reason being is because you still need that extra footage to exit whatever it is you're climbing from, or the exit the ladder in a safe manner, right? So if an excavation is 5 feet or deeper, you need some kind of cave-in protection, and that is required under any soil condition. Um, I say that, right? Some of you have probably been through trainings and they say, oh, for type A soil, you don't need it. However, good luck finding type A soil, right? I mean, that would be like solid rock that hasn't been scraped and fissured, or hasn't, been, let's see, impacted by the excavation, right? So really, just know that if you're 5 feet or deeper, put in some kind of a shoring system or a cave-in protection system to keep yourself safe. I mean, that's what it comes down to. Um, in unstable soil conditions, kind of like a Class C type soil, you might have to do either sloping, because shoring isn't a possibility because the sides will keep caving in, or you have to put in, some kind of shielding or a shield, a shoring box or shield box, because shoring isn't gonna work in those types of soils, right? And then last number that you need to be really aware of is that spoils shall be a minimum of 2 feet from the edge of the trench. And then in addition to that, they really shouldn't be higher than 2 feet, right? So 2 feet over and then no more than 2 feet high. If it's much higher than that, you still run the risk of things rolling off the top of your spoils and then falling down into the trench. So at some point though, obviously, you can't have things stacked 15 feet high and 15 feet away. That's not a good use of your space in your excavations because excavation is, considered the most expensive part of any job. Confined space. I think anybody who's been in this industry long enough has spent at least some time in a confined space. Trenches can be considered a confined space, or you're going down into some kind of vault. Um, Again, they have a 24-hour confined space training course. Like you can spend a lot of time on this, and it's important because you need to be aware of all the hazards that may exist. Um, so you want to establish that minimum training. You want all personnel who are going to be at entering or involved in the confined space entry to be documented. So you have an entrant, you've got a supervisor, you've got an assistant, or something like a top man, if you will. And so you want to make sure that you document everybody who's going to be going in, who's going to be on standby, and who the supervisor is, right? So that's a minimum of 3 people who have to be involved in every permit required confined space or non-permit required confined space. Um, the procedure or procurement of safety equipment, right? You want to make sure that you have everything you need that's going to keep you safe, whether that be a harness, um, you know, uh, air monitoring equipment, right? That's going to be your biggest one, and how to test the confined space properly. Um, you want to you should have an inventory of all the hazardous conditions that exist in those confined space. You should be well aware of them prior to entering in any confined space. And then it says, written procedures must be located on site, but that could be a book that you take with you. You could leave it in your truck. So it doesn't actually have to be um, physically at the site if you can pull up its reference, either on your phone or, if you have it with you in your vehicle. Okay. Continued, in the past, due to lack of safety precautions, hundreds of people were dying each year in confined space. This is true. A lot of people have died in these confined spaces for various reasons: engulfment, toxic environment, flammables. There's just a ton of reasons how a confined space can kill you, and most of them are invisible initially, right? You don't see them, which is why people become complacent too, because if you're constantly going in and out of confined spaces and it's just no hazard after no hazard, you could find yourself, there could be methane that's in the soil. You know, you can't see methane, and methane will displace oxygen. And if you go down into a confined space and there's no oxygen, you're going to likely pass out prior to even realizing that there's a lack of oxygen in there. Um, so in 1993, OSHA stepped in and established standards for confined space entry. And, you know, obviously since their involvement, the numbers have decreased and yeah, but still, any death is unacceptable, right? So that's why you got to take this stuff serious. Okay. What is a confined space? Well, there are a couple requirements, if you will, to meet the definition of a confined space. It has to have limited or restricted means of ingress and egress or entry and exit. Large enough for an employee to enter and perform work, right? So, you got this image here of this guy working inside what, is probably the equivalent of a hot water tank, right? You're probably not capable of working in there. But then it cannot be designated for continuous occupancy, right? If it's a workspace where there's a desk and you're in there frequently, that's not a confined space. So, few examples there you can see vaults, meters, sewer access holes, tanks, wells, digesters, reservoirs. Those are all considered confined space. One thing you could add to that is trenches. Yeah, trenches can be considered a confined space. So, to wrap things up, you got permit required confined space and non-permit required confined space. Both, in my opinion, are equally as hazardous, and they should both be treated with the utmost precautions. Um, but the definition is provided for you here. For a permit required, it contains or has the potential to contain a hazardous atmosphere, contains material that is potential for engulfing, which is burying you. Well, there's a long list, really. It just, shock, it could be drowning. There's a ton of different, materials or potentials that could um, create a problem for you. And it has internal configuration such that an entrant would be trapped or asphyxiated by inwardly converging walls or by floor and slopes that slope downwards, and contains any other recognized serious safety or health hazard. Non-permit required confined space is a space that does not contain any of the permit required conditions. Uh, but in all honesty, I've yet to see a non-permit required confined space that cannot or does not potentially have something that uh, could elevate it to the level of a permit required confined space. All right, oxygen ranges. I've seen this question on interviews. I've seen this question in distribution exams. So you should be pretty familiar with this one. And the range is 19.5 to 23.5. Um, if you've ever been in confined spaces, you'll find that the normal oxygen range or number is 20.9. So if you've ever been, out there, taking measurements, because when you go into a confined space, you have to take readings continuously, and as you're monitoring the atmosphere, and that number, is always, it should be 20.9 at all times. And if you start to see it dip or you start to see it rise, you should be pretty well aware that, something is not right. Um, So you can see that there's, some of the, health effects here on the right, um, that the lack of oxygen or an increase in oxygen can create for you there. When you're entering, or excuse me, before you enter a confined space, you obviously need to measure the quality of air in that space. And so the proper procedure for doing that is measuring it at many different levels, right? Because some gases are lighter than air, so they're going to be, higher in the vault. They're going to, or there's some gases that will be that are heavier than air, so those you'll find at the bottom of the vault. Um, so that's why you want to measure at these many different levels, right? And so you also need to take into consideration how long does it take for air to enter into the hose, um, and reach the equipment for reading, So one of the things you could do is you could blow at the end, like blow air into the end of your hose after you've got it turned on and calibrated, and see how long it takes for that to reach the equipment, right? So in some cases it might be 20 seconds. So you don't want to just drop in your hose, measure for 2 seconds, nothing's happening, drop it down further, nothing happened, and then drop it down to the bottom, still nothing's happening. But you might, cover the entire depth of that confined space prior to, the equipment actually getting any, valid readings. So that's why it's important to measure at multiple different levels in any confined space.
Piano.
So, how do we change the atmosphere when you do have, or you do detect, something in the atmosphere that's not good for you, right?
Mhm. Blowers.
That's right. Blowers are how we, um, move air into and out of a confined space to improve the atmosphere in there to make it suitable for working conditions, right? So when you turn a blower on, at a minimum, you want to purge that hose, that yellow hose that you see there. You want to purge that for about 1 minute in order to get anything that may be in the hose out, right? And so what you're looking to do is change the environment approximately 3 times. So you'll have to do a little bit of math and figure out how large, how much square footage is inside a confined space. And then if you look at your blower, there's going to be a CFN rating on it, and that will let you know how many cubic feet per minute that these blowers, purge at or blow at. So that way you can have an idea of how long you need to purge your environment prior to making it safe for entry. Okay, so in order for your ventilation to be effective, you want to make sure that, you're forcing air into the space at one end and then taking that air out at the other end, right? So you're getting ventilation across the entire confined space. So in the example in the middle, you could see that you have a ventilation going in at one end and air coming out at the other end. However, the air that's being used to pump into the confined space is being pulled from the air that's being pushed out of the space, right? So that's why you want to be, aware of where is that supply air coming from. If you're uh, near traffic, you don't want to have the ventilation or the supply air uh, coming from, or the being pulled in from the road, right? You don't want exhaust going into your confined space, right? So these are some of the things that you need to take into consideration when you're setting up your blowers for your confined space. And of course, like I said previously, confined space, there's a ton of documentation that needs to go along with it. You want to know who's going in, where the site is, what time you'll be there, what were the continuous readings, and all of this is to keep you safe, right? You you want to make sure that you're doing this properly, because if an incident happens, and let's say that you know, you were involved in some way, you were on site, you were the supervisor, whatever it may be, right? You want to make sure that um, your position in the incident is defensible. So making sure that you're documenting everything properly is how you're going to keep yourself defensible. Without documentation, you don't have a case to support yourself. So, um, things to consider. when working near a confined space, right? You want to make sure there's no flames within 10 feet of that confined facility. Um, some gases obviously weigh less than air, so if you open the hatch and those gases are leaving the confined space and there's a flame nearby that could ignite, you could have some serious problems, right? And then, of course, atmospheric monitoring has to be continuous. And you want to make sure that after you've tested the environment from top, middle, bottom, that you have that continuous monitoring near the level at which your breathing is going to be at. You want to make sure that you're monitoring the environment at that elevation because that's what's going to affect you, that's what's going to let you know that there's something going wrong at your elevation of working. And so if you're 5 feet tall or 6 feet tall, that lets you know, kind of where you need to have that hose at. Any questions on confined space? Please let me know. Like I said, again, as much as it may seem that I went into the details on confined space, really there is a whole lot more to it. Okay? Moving on, we got hand tool safety, right? You want to make sure that you're always using the appropriate tool for the job that you're performing. You frequently want to check the condition of that tool. As you use tools, their condition is going to change. If it's a power tool that has a cord, that the protective coating on those wires gets cut open or frayed, you may need to get rid of that. The blade on your chop saw gets worn down. You want to change those things out, right? You want to make sure that you're constantly checking your equipment to make sure that it's still in proper working condition. Um, Again, you want to make sure you have the proper PPE when you're working with any kind of hand tools. And you don't want to just lay them on top of step ladders because obviously that creates a fall hazard, right? So there's a lot of hand tool safety requirements that you should be aware of. Power tool safety, right? So again, you want to make sure that your electrical power tools are grounded with a GFI, a ground fault interrupter. Um, Power cords should be inspected frequently, and you don't want to lift power tools by the cord. That's how they get damaged, right? The power tools have hand grips, so you want to make sure that you're using those. You want to make sure you have established firm footing before you're using that. As you turn on a piece of equipment, it creates a jolt sometime, as it's turning over a blade. So being aware of those things. Air tools can obviously be very dangerous. If you've got, some kind of a compressor with a high pressure air hose, you want to, that can create a hazard for you, right? You don't want to be wearing jewelry or loose fitting clothing that can be pulled into the power tool as you're using it. These are all things to keep in mind as you're using these tools. All right. This is a very important topic as well. Let's just kind of go over the high points here. You want to make sure that you have the proper cones and signage as traffic approaches your work site. You want to make sure you have a proper taper, and that's what kind of sets up your cones to push traffic over and around your work site. You don't want to have a really short taper and not give people proper time to get over. Otherwise, you're creating, the potential for traffic accidents. If accidents happen outside of your work area, you can be liable for that incident. So if you're, let's say, working on a water main and you're having to pump out your hole and that water's gone down the road, let's say 200 feet, for example, and a guy riding a motorcycle um, loses control and falls and, gets injured, let's say, you could be liable for that, even though it didn't happen in your workspace. You've created a changed condition in that environment that, may not typically be there. So be aware of those types of factors. Like I said, you want to place your traffic control far enough ahead of the work site to give everyone an early warning that, hey, there is a change condition coming up and you're, this road that you've driven down for the last 25 years and have never had to, be inconvenienced by. You're about to be inconvenienced by, all right? Everyone involved must wear traffic rated reflective vests, and that is a type 3 vest, right? That's the one that goes down to your shoulder or down your upper arms. You want to make sure you have an approved traffic control plan or a TCP anytime you're working in the road, right? Unless it's an emergency situation, if you have scheduled work, then you are working with the local agency to get yourself that traffic control plan, right? And then, like I said, if an incident occurs, you could be held liable.
Dad. Safety.
All right. By now, I'm sure a lot of you have noticed those little placards with the white, blue, red, and yellow designations on it, and then the number associated with it, right? Those are important because those will let you know the reactivity or the health hazard associated with the chemical that you're working with. Um, right? So these disinfection or treatment chemicals can be very corrosive, and not only to like metals or pipes or anything like that, they can be corrosive to your skin, right? So you got to make sure you're taking the proper care and wearing the proper PPE anytime you're working around chemicals. Also, you want to become very familiar with the SDS, formerly known as the MSDS, right? So that stands for Safety Data Sheet. There's 16 sections to it. We're actually going to dive into that a little bit later on. Um, but the safety data sheet is very important to become familiar with because it'll tell you everything you need to know about that chemical, right? It'll let you know how to safely store it. It'll let you know how to safely handle it. If you come in contact with it, how do you treat that, right? So it'll give you everything you need to know about it, right? The diamond off to the side here, though, I don't believe I've put any questions on it, so don't feel like you need to memorize everything about it. You might see it on your homework, but that would be about it.
Dad. From we have equipment safety.
Yes. Obviously, heavy machinery or any kind of vehicle can create a safety hazard. Like you could see in this image here, you've got a bunch of guys who are using a backhoe to create shade. Obviously, that's a very hazardous scenario there. Should a hydraulic hose break and come crashing down on top of them, uh, you don't want to put yourself in any kind of situation like that, obviously. So, vehicles include trucks, cars, backhoes, loaders, excavators, etc. You want to be aware of any potential dangers associated with the vehicle that you're operating or working near. Just because you're not the one operating it doesn't mean it won't hurt you. You want to be aware of your fellow workers, right? That's why you're wearing a road vest, so that way you stand out more. But you also want to be aware, if you are working, like let's say near a sidewalk that pedestrians frequent, you want to make sure that you're aware of your surroundings and the people surrounding where you're working. You definitely want to maintain a vehicle inspection log. Should you get into an accident, and you don't maintain a log for your vehicle, it could lead to, again, litigation, because all of that stuff will be used against you. You want to follow your employer's fleet safety policy program, and that's going to include driving speeds, just how you should be operating any kind of heavy machinery or vehicle. And then there's the obvious stuff, right? If you're operating any of these vehicles, you don't want to be eating food. You don't want to be on your cell phone. And if you're tired, you especially don't want to be operating that piece of equipment, right? Because all of those things can lead to safety hazards. All right, that includes the first half of our lecture. I'll see you when we start up the second one.